Hello and welcome to another video where we're going to be talking about moles of a gas. So in this video we're going to talk about how much 1 mole of a gas is, and we're also going to talk about how that is used in gas calculations. So let's get straight to it with the definition of what 1 mole of a gas is. So 1 mole of a gas equals 24 decimeters cubed. Okay, that is what you need to just remember about this whole topic. 1 mole of a gas equals 24 decimeters cubed. Now that is any gas. Okay, so it could be hydrogen, oxygen, chlorine gas. It could be any kind of gas. If you've got 1 mole of it, it will occupy 24 decimeters cubed. So what's the difficult part in this? Well, the challenging part is just to remember what decimeters cubed is. Okay, so this also equals 24,000 centimeters cubed. So the key thing that you've just got to keep an eye out for here is the units. So you've got to keep an eye out for the units in the question, what it's asking you to give the answer in, but also when we're looking at that question, what's it given you the volume in? Because one of the things that they'll test you for here is whether you can convert between decimeters cubed and centimeters cubed. So I hope what you can notice is the conversion between the two. If I wanted to go from decimeters cubed to centimeters cubed, what I need to do is I need to multiply by 1,000. If I wanted to go from centimeters cubed to decimeters cubed, I need to divide by 1,000. Okay, so that's just a key thing to remember there. How could they ask you a question to do with moles of a gas? Right, well, let's have a little look at an example. It could simply be, what volume, okay, I'll write the question out, what volume is, and then it might have in decimeters cubed, and then you could get a question that says 1 mole of hydrogen. Okay, so if we've got this question here, 1 mole of hydrogen, what does it equal? Well, we've got here 1 mole of a gas equals 24 decimeters cubed. So if I was to actually write out what the equation would be, it would simply be the number of moles, which is 1, multiplied by 24. Okay, so that's the actual equation. So if I wanted to know my volume of a gas, okay, and this would be in decimeters cubed, what I would do is I would take the number of moles and I would multiply it by 24. And if I wanted that in centimeters cubed, I would multiply it by 24,000. So here we've got 24 decimeters cubed. Okay, a second question could simply be 3 moles of hydrogen. Now remember, this hydrogen could be any other gas, it could be oxygen, it could be anything, it doesn't matter what that gas is. Here I would have 3 multiplied by 24, okay, which gives me the total of 72 decimeters cubed. Okay, so on to a third question, here we go, 0.5 moles of H2, and what we would have here is 0.5 multiplied by 24, which equals 12 decimeters cubed. Right, so that sounds easy enough. Why don't you have a little go at it? Right, so here are some questions for you. Just 4 little questions. First set asking you what the volume of gas is in decimeters cubed, and the second is actually asking you how many moles the different volumes are. So think about what you've got to do there with the equation. Now, with regards to what information you have in your exam, I've left it on the board. I've left it on the screen for you. Okay, so you will be told that 1 mole of a gas equals 24 decimeters cubed and 24,000 centimeters cubed. That's given to you in sort of like your book of data. So you will have that information there, so I'm leaving it there for you. Okay, so have a go at those questions, pause the video, and then check back to see if you're correct. So let's have a look and see how you did. Okay, so what volume of gas in decimeters cubed is the following? 2 moles of oxygen. Okay, so it's 2 multiplied by 24, which equals 48 decimeters cubed. Okay, we're just using that number of moles multiplied by 24 to get us our volume. Okay, what about 0.25 multiplied by 24? Well, that equals 6 decimeters cubed. Okay, on to the next one. How many moles is 18 decimeters cubed of methane? So let's think about what we've got to do here. We know, okay, that the number of moles multiplied by 24 equals our volume. So if we're provided with the volume and we're trying to work out the number of moles, we just do a little bit of rearranging here so that we know that the number of moles equals the volume divided by 24. Okay, so over here we've got 18. So what we've got is we've got 18 divided by 24. Okay, and this will give us the number of moles, which is 0.75. Okay, and again here, same thing, we've got 120 decimeters cubed, divide that by 24, and that will give us the answer 5 moles. Okay, so hopefully that moles of a gas seems simple enough in principle. So let's look at it in a more complex question. Here's an example of a question that sort of brings everything a little bit together. So what volume of hydrogen is produced when 4.86 grams of magnesium is reacted in excess sulfuric acid? Give your answer in centimeters cubed. So let's highlight a couple of things before we get straight into the question itself. So whenever I look at exam questions, I always talk about highlighting the important information. So the first bit of important information is the volume of hydrogen. That is my question. Produced when 4.86 grams of magnesium. Okay, so I know how much magnesium there is. And also, I know that we've got excess sulfuric acid, so I don't have to worry about the number of moles of sulfuric acid. The other thing that's really, really important here is giving my answer in centimeters cubed. So I'm focusing in on that as well. Okay, so when we look at this kind of question, it's a combination of that reacting masses stuff that we did earlier in this series of videos and what we're doing in this video. So let's put the information in that we're after, or that we know and that we're after. So we're after the volume of hydrogen, okay, so I can put a little question mark under my hydrogen because that's what I'm after. 4.86 grams of magnesium, and I know that this is in excess, okay? I'm just going to write excess there. So I don't have to worry about my sulfuric acid. So what I can then do is I can then start to construct the scaffolding that we've done previously. Okay, so here we've got our mass, and then we have our RAM, and then we have our moles, and then we have our ratios. So here the relative atomic mass of magnesium is 24.3. So when I look at the number of moles, I've got 0.2. When I come to doing the ratios, I look at the big numbers in front of things. Okay, there's no number there, so they're both 1, which means it's a 1-to-1 ratio. Which means that over here, I've got 0.2 moles of hydrogen being produced. Now this is where it's slightly different from the reacting masses. As previously, we would have then gone to work out the mass of hydrogen being produced. This time we're looking at the volume. So what I've got to do is I've got to take this number here, this 0.2, and I've got to multiply it. Okay, now I've got an option here. I could multiply it by 24 and then convert it, or simply what I could do is just multiply it by my 24,000. Why am I using 24,000 instead of 24? Well, that's because of that last little bit of the question that says give your answer in centimeters cubed. Plug that into my calculator and I get the answer 4,800 centimeters cubed. Okay, so very similar to what we've done before, only the end is slightly different. So, as always, I'm going to give you a little question to have a go at this. Check back in like 2 seconds and it'll be there. Right, so here's that question. What I'm asking you is what volume of carbon dioxide is produced when 4 grams of methane, CH4, is burned in excess oxygen? I would like you to give your answer in decimeters cubed. I've provided you with the relative atomic masses of carbon and hydrogen. That should be everything you need. So have a go, pause the video, and then check if you're right. So, how did we do? Well, let's have a look. First things first, what I hope you did is you went through the question and looked at the important parts. So what we first got is we've got this idea of the volume of carbon dioxide. We've got 4 grams of methane. We've got excess oxygen. And we need to give our answer in decimeters cubed. So let's put in the information from the question. So we're after the volume of carbon dioxide. We know we've got excess oxygen, and we also know that we've got 4 grams of methane. So again, we can put in our little bit of scaffolding here. Okay, it's a nice way of doing these kind of questions. Okay, so we've got our mass, our relative atomic mass, our moles, and our ratios. So here, the mass of methane, well, we've got to work that one out. So CH4, so that's 12 for my carbon, plus 4 times 1, which gives me a grand total of 16. So I have 4 and 16. Remember, when we're going down, we divide. So here I end up with 0.25 moles. My ratio is a 1-to-1 ratio, which means I've got 0.25 moles of carbon dioxide. Remember, this is the bit where we do it slightly differently from reacting masses, in that we take this number, because we know how many moles of carbon dioxide there is. We multiply it by 24. Why am I using 24? Well, that's because my question is asking me to give it in decimeters cubed, which means that I come up with the answer of 6 decimeters cubed. Right, so there's loads of different ways that these could be combined into questions, along with concentrations and all sorts, and I hope I've given you a flavour of some of those. I'll do a video near the end of this topic as summary, and where I bring them all together, and I'll give you some challenging questions to have a go at. So, in summary, what we've looked at in this video is we've looked at how much 1 mole of a gas is, and that's any gas whatsoever, and how we actually do some sort of simple mole of a gas calculation questions. So, as always, give the video a like, subscribe to the channel if you haven't already. It's great to have your support, and as always, I'll catch you in the next video.